So trigonometry then, to do with right angle triangles. So particularly used to resolve vectors. It's my focus for today. You've been doing that, I think, in mechanical principles. So this will hopefully reinforce what you're doing in there. Okay? Use of sine, cosine, tangent, Pythagoras in right angle triangles, and particularly used with vectors. Not vectors, vectors. But before we start that, I want to just a short introductory drill to find out what we know already about right angle triangles. And so calculators are allowed in this little drill. Only 3 questions. I'm not going to collect this one in. It's by way of introduction. So the first question, there's a right angle triangle. Find x. We'll go through it now, I'll pause it, and then we'll go to afterwards the solutions. So number 2, find the area of this triangle here. Find x. Okay, let's go through these things. So this introduction then, the first question is to do with what? What you need to be able to do number 1. Says that a squared plus b squared, the 2 short sides squared and added together, equals the long side squared, which is the hypotenuse. So the hypotenuse is always one opposite the right angle. So if I want to find c, that's the square root a squared plus b squared, because whatever, when I do it, I want to see c squared is what my Pythagoras gives me, so I need to square root at the end. So why not square root at the start? This is how I put it into the calculator. Once the hypotenuse, I put the square root button on the calculator, and then a squared plus b squared and so on. However, we want one of the short sides, so I need to rearrange this formula. Plus a squared, doesn't matter which better, a squared or b squared. So I'd actually subtract. So this leads us to the other common formula, which is one of the short sides equals the hypotenuse squared minus the other side squared, and then that will all be inside the square root bracket. A very, very familiar formula that you use when you're resolving forces, and all the time in anything to do with structural engineering when you're finding lengths of steel girders, etc. Right angles often. So that you should remember. I didn't give it to you, I was expecting you to remember that that is the case. So now all I've got to do is plug in the numbers, so therefore x is going to equal the square root of the hypotenuse squared, which is 12.5 squared, minus the other side squared. So you do that in one hit on the calculator, hit the square root button and put the numbers in, and you get the answer. Everybody? 9.4, is that rounded? So, 2 significant figures. I didn't give you the units, so 9.4 to 2 significant figures. Is that appropriate accuracy? Would you say? Yeah. So this one's to 2, so you could go to 3 to 6, but that's fine. 9.4. You need to be able to do that. Number 2. Find the area of this thing. Area is half base times height. If we look at the rectangle, the triangle is half of, you can sort of see that it's half of that. So it's half of the base times the height. And it doesn't matter which side we call the base, whether we call that the base or that the base, is immaterial. It's half of 8.4 times 4.6. So the area is a half base times height. You can actually show that it doesn't matter where the triangle is. I won't prove this particularly, but if the triangle went like this, it's still half of that rectangle. So the area is half base times perpendicular height. We're going to come across that. In fact, we have done already when we talked about finding surface area and volumes of shapes. We're often after the perpendicular height. So this height here is the perpendicular height. So, not uncommon, if that make that a right angle, to use Pythagoras to find this perpendicular height. So again, Pythagoras comes into it. If I wanted to find the area of a triangle like this, I would find half of the base times the perpendicular height. So the area is going to be half times the base, doesn't matter which one, 4.2, so it's about 50, something like that. 52.92, is that appropriate? Not squared, no. Whatever this unit is, it's square whatever the unit is, but the number's not square. Who was it said square? Yeah, the unit squared, yeah. So if this was in centimetres, and this was in centimetres, and they have to be the same units, of course. If they're not, you must make sure they are, then the answer would be square centimetres. But is that an appropriate accuracy? Probably not. If you look at the numbers we put in, that's only 2 significant figures. So you can go to 3, but not 4, so 52.9 or 53 would be more appropriate. Last question, number 3, brings us into today. Anybody come up with an answer for this one? And if you did, what did you do? Good. Sine 40 times 12.8 is the answer. So why is that? Yeah. This is the thing you need to remember. If you don't remember that little rhyme or something similar that does the same sort of thing, remember it. What's it telling us? If we look at an angle, in this case this is the angle, so the angle is 40 degrees. Whatever that angle is, the side opposite, the angle is called the opposite. So if this was the angle, here, that was 40 degrees. Oh, that was 40 degrees, do a circle. Then this would be the opposite side. Okay? Try not to do a circle. So the opposite depends on which angle you know. So in this case, the opposite is opposite, the one opposite is opposite. Therefore, this side next to it, adjacent, if you live adjacent to somebody who lives next door, adjacent to the angle. So that's the adjacent side, and this one's always a hypotenuse. So that's what the O, the H, and the A represent. O in this represents the opposite side, H the hypotenuse, A the adjacent. S for sine, C for tangent. So this is telling me that the sine of the angle is the opposite over the hypotenuse. That's the way it reminds me of this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Cosine is adjacent over hypotenuse. And finally, tan is opposite over adjacent. This is what that's telling me here. So if you don't know this thing, learn it, because we use it all the time. In fact, you probably are already in the unit resulting forces. So I know that this triangle is associated with the sine, the opposite of the hypotenuse, because I'm after x, the opposite of x. I know the hypotenuse, so therefore it's to do with the opposite of the hypotenuse, so it's to do with the sine. So sine theta is opposite over hypotenuse. As is always the case in these particular questions, if I'm after the opposite, I just multiply both sides by h, so opposite equals the hypotenuse times the sine of the angle. That I remember. So Stuart, you're dead right. So now to put these numbers in, x is what I'm after, so that's equal to the hypotenuse, which is 12.8, multiplied by the sum. And if you would like to just put that into a calculator, please. If you've not done this, do it now. And what do you get as the answer? So I have to do it formally. Sorry? 8.2. Rounded. So too significant. Agreement? Okay, good.